Welcome to the first of 3 webinars over the coming weeks on different aspects of SZ4D, or subduction zones in 4 dimensions, a new initiative to investigate processes that underlie subduction zone hazards. I'm Matt Haney with the Alaska Volcano Observatory. Today we'll hear from several people helping to advance volcano science within SZ4D, part of the group called Magmatic Drivers of Eruption. We'll get an update on progress toward an implementation plan and gather feedback and input on this process. During the presentation, please keep your microphones on mute. And if you have questions, type them into the chat window. We'll have time at the end to answer them. Next slide, please. All right, so the Magmatic Drivers of Eruption group. This is comprised of interest group members, working group members, and members from the SZ4D steering committee. You'll note here on the slide, there's over 150 interest group members already signed up, and they get updates from SZ4D. So thanks for already signing up. And today we'll hear from several of the working group members and members of the steering committee. You can also keep up with the Magmatic Drivers of Eruption group at the SZ4D website, shown in the lower left, and you can follow SZ4D MDE on Twitter. Next slide, please. All right, so what do we want from you today? Well, we would like your input on these 3 items. First, sign up for the interest group if you haven't already. And then also, please take our general survey if you have not already. This was a survey we put out a couple weeks ago to begin gathering feedback from the community. And then also after this webinar, take our webinar-specific survey to answer questions related to the topics we'll talk about today. Next slide, please. And before we really get into our presentation today, I wanted to give some introductory remarks and background on SZ4D, the parts that are already now being funded by NSF, which is comprised of 3 research coordination networks, or RCNs. First, there's the SZ4D umbrella. That's the RCN that we're part of, and that's led by Harold Tobin. There's also the SZ4D Modeling Collaboratory, and this is led by Thorsten Becker. And there is the third one, Converse, the Community Network for Volcanic Eruption Response, led by Tobias Fischer. And Converse was partially coming out of the National Academy's Erupt report in the past couple of years. So already NSF is supporting these planning activities for SZ4D. And I'll also mention that SZ4D was mentioned prominently at several parts of the recently released CORS report, shown here on this slide, by the National Academy of Sciences. Next slide, please. All right, so the SZ4D umbrella RCN, that's the part that that's the RCN that we're part of. And the umbrella was described in detail by Harold Tobin in a webinar in late April. And if you haven't seen that, I encourage you to go to the SZ4D website. A recording of that webinar has been posted. So the goals of the umbrella RCN is over these 2 years to turn the vision that was enunciated in the report that came out of the Boise subduction zone meeting in 2016 into an implementation plan. So really, take the vision, think of the big science, and in a community-based and community-driven process, translate that into an implementation plan that makes a compelling case for a new decadal science program. And the open questions are the scale and scope of such a program, and also the scalability of the program. And then practical matters like where will we go? And here also you'll see we've already begun forming interest groups and working groups, and the umbrella RCN will work with partners and funding agencies to make a viable and compelling program. Next slide, please. And then within the SZ4D umbrella RCN, we have these 3 working groups. And as I mentioned, we'll be hearing from them over the coming weeks. Today, you'll hear from Magmatic drivers of eruption. And then next week on June 19th, we'll hear from faulting and earthquake cycles. And then in 2 weeks, on June 26th, we'll hear from landscapes and seascapes. Next slide, please. And before we really get into the presentation, I was just going to give a couple of examples of the exciting science that's making us think about such an ambitious program. First one shown here are gas fingerprints, gas measurements at volcanoes using multi-gas instruments, here shown at Masaya and Turrialba volcanoes. And specifically, looking at changes in the carbon dioxide to sulfur ratio that precedes eruptions, as shown in this recent paper by Damore and others at Turrialba. This is a measurement that was also reported at Redoubt volcano before its 2009 eruption by Werner and others. So this is exciting, seeing the ascent of magma, the fingerprints of that process in data prior to eruptions. Next slide, please. And then the second one I wanted to highlight is crystal clocks. This is looking at time-dependent aspects of the crystals that are in the products of volcanic eruptions. These crystal clocks enable the determination of eruption initiation mechanisms. And as shown here in the lower left, a recent paper by Rasmussen and others looks at a multi-parameter data set, including seismicity, remote sensing, and crystal clocks to look at the run-up before the 1999 Shishaldin eruption. So the question here is, can we tie the underlying magmatic processes to what their surface signals are? And with that, I am going to turn it over to Adam Kent, and he'll describe some of the scientific framework we've begun putting together.
Hi, Matt. Hi, everyone, and welcome. This is Adam Kent from Oregon State University, and I want to start to introduce the framework for the SZ4D Magmatic Drivers of Eruption Working Group. In this working group, we're going to address a central question in volcano science, which is how do transcrustal processes initiate eruptions at arc volcanoes? This question is based in the long-known idea that arc volcanic systems are underlain by extensive regions of crustal magma storage and transfer, often referred to as magma plumbing systems, but increasingly being referred to as transcrustal magma systems in recognition of the fact that they extend throughout the entire crust and into the underlying mantle. There's also an increasing recognition that to understand volcano behavior in its entirety, we also need to understand this transcrustal system in its entirety. The idea of eruption initiation is also central to the framework we were discussing, as we see it as a critical part of the volcano eruption style, especially when we consider issues of volcano monitoring and forecasting volcanic behavior. However, I will note that our current definition of initiation is also deliberately broad, referring simply to the processes and mechanisms that move a volcanic system from a state of quiescence to a state of activity with magma ascent occurring. Our framework also reflects the increasing recognition of transcurrent magma systems as very dynamic regions that are complex in terms of their geometry, the range of compositions and the phases that are present, their temperature, their rheology, and other factors. And they're also hosted in an equally complex crust. Processes that occur within this transcrustal system produce conditions that allow for the initiation of volcanic eruptions, but also control many other aspects of that eruption, such as duration, magnitude, style, etc. We also recognize that processes that are occurring within transcrustal systems are occurring at a broad range of spatial and spatial scales and timescales. For timescales, this goes from the very short timescales associated with eruptions themselves through to things that are truly geological in extent. And understanding processes within the transcrustal system thus requires a broad variety of types of investigation, ranging from studies of active systems that use many different tools through to geological and other observations of exposed crustal magma systems. Next slide, please. So our working group has developed a 4-part framework to help us address this central question of how do transcrustal processes initiate eruptions at arc volcanoes. This comes from extended discussions within the working group and also with the other SZ4D working groups. It also comes from the input and discussion from the original Subduction Zone Observatory conference or meeting that Matt talked about, which was held in Boise in 2016, and from the excellent SZ4D that came from that meeting. In addition, many other workshops, meetings, conversations with colleagues, and also reports from the national academies and the USGS have also been influential. Our framework is 4 parts. Volcanic eruptions. First part, volcanic eruptions are thought to be initiated by a range of internal and external mechanisms. These mechanisms produce overpressure, tensile failure, and or shear failure or other conditions that cause eruptions to initiate within the transcrustal magma system. In turn, there are variables describing that magmatic system that control the specifics of these failure conditions that are necessary to initiate eruptions. And finally, the mechanisms of initiation, ultimately controlled by the transcrustal magma system, lead directly to the resulting eruption style, composition, eruptive volume, unrest behavior, and initiation timescales. We're going to talk about each one of these framework elements in turn, and I will continue to talk about the first framework element. If I can get the next slide, please. So the first part of our framework deals with eruption initiation mechanisms themselves, and we've divided those into external and internal initiation mechanisms. As shown here, internal mechanisms, as shown in this schematic, are those that relate to the igneous and the other processes that occur within the magmatic system itself. Thus, the range of internal mechanisms shown here in this figure, and also in the written summary on the slide, reflect the processes that occur during storage, evolution, of transfer of magmas, whereby magmas of different compositions and different physical properties interact, and or where accumulation and exsolution of vapor occurs. Evidence for these processes is often preserved in the erupted products themselves, but can also be evidence for these processes can also be for a very broad range of other observations. Next slide, please. The second set of initiation mechanisms we identify are those that are external to the volcanic system. Although these are less well known, they are also important and include the potential for landscape changes to initiate eruptions, such as shown in the example of the landslide at Mount St. Helens in 1980, which is on the left, as well as the concept that earthquakes of different magnitudes can initiate eruptive activity, as shown in the figure on the right. Examining external initiation mechanisms such as these provides a very natural and a very strong way for us to link our working group with the other working groups in the SZ4D initiative which deal with issues of landscape and also issues of earthquakes. An additional important point is the extent to which a magmatic system is primed prior to an eruption being initiated by some external mechanism, and thus understanding the feedbacks between external processes and what is happening in the transcrustal magma system itself is also critical. Now to talk about other aspects of this framework, I'd like to hand over to my colleague, Chris Huber.
Hi everyone. Thank you, Adam. I'm Chris Huber from Brown University, and I will follow up with the second item of the scientific framework, which basically focuses on the state of the host crust during the run-up time that leads to an eruption. And you can see two figures that illustrate the power of coupling long time series that could be drawn from GPS datasets or seismicity with physical models. For instance, on the right, using finite element methods to calculate the stress field around the chamber. And those are really instrumental in understanding the conditions under which the container fails or before and during an eruption. Next slide, please. So the third item in our framework focuses on the mechanical processes and the physical properties of the magma that can basically affect the state of the magma and the host leading up to the initiation process. And it's looking into variables such as the magma input rate, the size of the magma body, its depth, and the volatile content. So both internal variables as well as the rheology of the crustal host. And the slides that I'm presenting here, the two figures that I'm showing you, are presenting two examples of those physics-based models and how they try to link or couple the internal dynamics within the magma body and that of the surrounding crust leading to different kind of systems and reaching those kind of conditions required for initiation. Next slide, please. Finally, the last item in our scientific framework, which is of major interest, is the fact that these processes that I described in the previous slide and that Adam also described are also influencing strongly the timescales and the physics leading up to those eruptions. So they have an influence, for example, on the duration of the run-up time. They have strong control over erupted volume, but also the style of eruption. So they directly connect to eruption dynamics and eruption behavior, and therefore hazards. And some of those processes are more likely to happen in different systems. For example, the composition of those magmatic systems can also modulate which process has the strongest influence. All right, as I will pass on to the next slide, I would like to turn it over to Ben Black.
Thank you, Chris. I'm Ben Black from CUNY. One of the foundations of SZ4D is that the broader subduction system is strongly coupled with volcanic hazards at arcs. This hypothesis grid that I'm showing here is one of the ways we're thinking about how SZ4D could systematically address hypotheses relating subduction zone variables on the left to eruptions on the right at a much more specific level within the bigger picture framework Adam and Chris just talked about. So just to walk you through this, on the left are some key questions regarding the subarc mantle and magma production in orange, the transcrustal magmatic system in green, and rheology and the tectonic stress environment in blue. And then here we have started to list hypotheses for how these subduction zone factors could influence different aspects of volcanism, including run-up, repose, and eruption style, ultimately helping us to better understand how the processes underlying subduction zone volcanism impact volcanic hazards. Next slide, please. So these hypotheses are meant as a starting point. The most important thing that we want to emphasize here is that, as Matt has already mentioned, we need your input. We invite all of you to go to the working group website, which is linked in the lower right here, and fill out the webinar survey, where we ask you to help us fill in this grid and identify the hypotheses the community thinks are important and testable, perhaps uniquely, through an initiative that's interdisciplinary like SZ4D. So next, moving even deeper than this hypothesis grid, Trish Gregg is going to talk about our efforts on traceability and carefully accounting for how SZ4D could address specific hypotheses.
Thank you, Ben. Hello, everyone. Thank you for joining us today. I'm Trish Gregg from the University of Illinois. As part of our working group's effort to provide a framework for targeting our overarching question of how do transcrustal processes initiate eruption at arc volcanoes, we have undertaken the effort to develop a science traceability matrix. The goal of this is to help guide future community efforts and targets. Science traceability matrices provide a critical overview of what a program will accomplish relative to high-level objectives. It provides a logical flow for addressing the overarching question and framework through a series of key elements. We start with the science objectives, which test a number of hypotheses as laid out in the hypothesis grid outlined by Ben in the previous section. Following directly from the science objectives are key elements such as project objectives, measurement objectives, observation modes, measurement requirements, requirements for the spatial and temporal scale of the program, all the way through to the necessary science products and science outcomes. The Science Traceability Matrix is a key document that illustrates the relationship between all of the key elements of the project. It provides the information needed to address the motivating science questions and develop an overall program design. The Traceability Matrix gives us scaffolding for developing a specific implementation plan. So as you can see, our current matrix is still in draft form. So of course, we welcome and encourage comments and suggestions to help us improve our focus and target critical scientific objectives. But I want to zoom in on one of the science objectives we have outlined to provide an example of how we've approached developing the traceability matrix. Next slide, please. All right, in this case, the science objective tests multiple hypotheses for understanding the factors driving decompression rate to eruption and the controls on the timing and rates of precursory runup. This science objective fits into parts 2 through 4 of our framework as outlined by Adam in the earlier parts of the webinar. Following from our science objective is the project objective to evaluate absolute and relative timing of eruption precursors from a background state and compare these to timescales of magmatic processes such as rejuvenation, timescales of volcano dormancy, and the degree of background unrest. The measurement objective is to observe background to precursory activity and pre-eruption mixing timescales. So it requires a number of observations from geology, geophysics, geochemistry petrology, remote sensing, and numerical modeling. Our measurement requirements include deploying sparse seismic, GPS, and gas networks on tens of volcanoes for 10+ years with rapid response sampling during periods of volcanic unrest. So as such, our spatial scale is sparse but relatively widespread, with the temporal scale ranging from long-term to the rapid response quick timescales. Science products for this particular approach include multiple time series of precursory activity and multiple volcano surveys of pre-eruption timescales. Finally, our target science outcome is an integrated understanding of the sequence and timing of observable precursors and how they link to magmatic processes recorded in erupted products, and an understanding of volcanic quiescence during the duration and the degree to the background unrest. So I'd now like to turn it over to Christy Till, who will discuss how we can use this traceability matrix to determine potential volcano targets and where we hope to take this from here.
Thank you, Trish. Hello, everybody. I'm Christy Till from Arizona State University. So we've heard nicely how we've been collating relevant hypotheses from Ben and how we can develop those into an actionable science plan via science traceability matrix from Trish. So a natural question arises where is the best place for us to go to test these hypotheses and to execute our science plan? So to work on this, we've started a compilation of global arc volcanoes that we're calling the Restless Volcanoes spreadsheet. You can see a screenshot of it here. So this is a compilation of 97 volcanoes, arc volcanoes specifically, that are actively emitting SO2, as compiled from Karn et al. In 2016, and or are actively deforming as compiled by Fortney et al. In 2018. And we're limiting to volcanoes that erupted within the 2000s. So 72 of these volcanoes are not continuously erupting. And if we monitored all of these 72 volcanoes, we would have observed 50 full eruption cycles between 2000 and 2009. And those would have had repose intervals of 1 to 5 years, or 35 full eruption cycles between 2006 to 2015, with repose intervals of 1 to 8 years. So you can see that there we can gain a lot of information about what might be good systems to go observe active eruptions through a process like this. So the compilation that you can see in the screenshot in front of you includes a list of volcanoes over on the left, which of these volcanoes are located in which of these compilations, their last previous eruption year. We're compiling the number of samples available through different types of repositories, and where there's geochemical or other types of data available on these volcanoes through things like the GeoRock, EarthChem, or NAVDAT databases. And then over on the right, you can see a grid of numbers. And so this represents the VEI, the largest VEI of an eruption within a given year over the last 20 years for each of these volcanoes. So it is through this process that we are envisioning taking our hypotheses and our science traceability matrix to start locating which volcanoes will be the best to study the kinds of things that we would like to study in a program through SZ4D. Next slide, please. So this compilation now lives on the SZ4D website on the volcanoes page or the magmatic drivers of eruption page. And we have versions there that you can scroll through or as well as download if you're interested. And what we want is your input. We would like to know which volcanoes you have worked or published on and what other volcanoes you think we might be missing from a list like this. Obviously, we're interested in those that have the potential to address things that require active observations, as well as the geologic record. So we welcome your information, and you can provide this information through our webinar survey that we mentioned before. Next slide, please. So where do we go from here? So this whole process of organizing the SZ4D implementation plan began in January 29 at the beginning of our umbrella RCN. And over the last year, we've developed working groups, and we've developed the work that we're sharing with you today through the Magmatic Drivers of Eruption Working Group. And here we are today having this webinar, collecting your input and asking for it continuing in the future through our interest group. Over the summer and fall, we're going to meet with the other working groups following their webinars to discuss their traceability matrices and the data they've gathered thus far about potential locations. We're also going to kick off an international working group and an associated webinar series. This is inherently an international effort, and it's critical to us that we engage all communities across the world who are interested in these questions through this process. And so we really are interested in making sure that we have your voice, but not only in where we will go, but also in framing the science that we will do through this program. So this is a special call out. We want to hear from you. We will start discussing the implementation plans over this summer and fall period. And the goal of this is to make sure that we have a cohesive program rather than 3 distinct programs. And we envision that we're going to develop possible implementation plans that span different scales and costs as we've been continuing to get input from the National Science Foundation. We have SZ4D wide activities at both the Geological Society of America and American Geophysical Union meetings. And we also have specific Magmatic Drivers of Eruption sessions and activities. So please keep your eye out for those. And we invite you to participate those, whether they are virtual or in person. So then the goal is by early 2021 that we will start having drafts of implementation plans to share widely and gather input on. And we envision these being sort of collated and finalized by summer to fall 2021, when they will be presented to the public as well as to funding agencies. So I'm now going to turn it over to Ayla Pamukcu to talk about what some of these potential implementation plans might look like.
Great, thanks, Christy. I'm Ayla Pamukcu from Stanford University. And when the slide switches over. So as Christy said, I'm going to talk to you about a couple of examples of implementation plans that we've been discussing, but we're going to be continuing to work on these and ultimately be asking for your input. So the first is this 2-phase approach where phase 1 is this really broad approach, a kind of reconnaissance look at things where we have sparse arrays applied to many volcanoes. So we have multiple sensors, but light arrays, doing some early petrologic studies on some most recent eruptions, but very broad in scale. And selecting the volcanoes for this will really be coming out of that, that volcano spreadsheet that Christy was just talking about, as well as our science questions, but also the accessibility, both in terms of safety and politics, and our ability to get open data in terms of data collection on these systems. The second phase will then be much more focused, where we really apply the whole enchilada, as we call it, to a subset of these systems. So here we're talking about really dense arrays of multiple sensors, so things like what we've been seeing in the IMUSH project at Mount St. Helens, looking at imaging and time series, as well as really delving into the petrology and the crystal records and the geochronology, applying experimental petrology, really you name it, and that's what we want to do with these systems. And so selecting these systems is really going to be coming out of those science questions we've been talking about and what we get out of phase 1 of this plan, but also how do these volcanoes relate across the different groups that we're talking about. So how can landscapes and seascapes and earthquakes and faultings also be getting information out of these systems. And then we want to maximize our ability to do outreach and minimize the hazards that are going to occur for people doing research at these systems. Next slide. We're also talking about a rapid response implementation plan. So what happens when an eruption actually occurs in real time, and we want to capitalize on that eruption event to get information. And so for this, we're talking about connecting with Converse, which was mentioned by Matt early on, and they're developing a rapid response approach. There's currently ongoing work on some resources and reports, and they'll be doing a dry run of their rapid response approach in 2021. We can also link to the IRIS Geohazards Initiative. And importantly, these may not be the same volcanoes that we're looking at from phase 1 on the previous slide. These may be new exciting opportunities for lab volcanoes in real time. And then of course, we want to, again, assess access and hazard risk for doing field work in these scenarios. Next slide, please. And then throughout this, as we think about our implementation plans, we definitely want to think about the related groups and research areas and how they are involved here. So again, Matt mentioned Converse at the beginning and the modeling collaboratory, both of which closely ally with what we're looking at here, but also experimental petrology, and of course, looking at the past to understand the future and the current state of systems. So looking at the plutonic and the exhumed volcanic realm. And then finally, there are many new technologies that are innovative and emerging, and these are things that we would like to bring to the table as we think about our implementation strategies. So with that, I'll send it back to Matt to kind of wrap things up and remind you what we need from you.
All right, thank you, Isla. Well, now I'm just here on the final slide, circling back to what we would like from you, these 3 items. You can see these at the SZ4D website. There's our survey that's specific to this webinar. And there's also the Restless Volcano spreadsheet posted on the website. And I wanted to thank Christy Till, Diana Roman, and Natalie Chow from SZ4D for putting those up on the website. And here's just a screenshot of that webinar survey that you can see there. So if there's nothing else, I wanted to, on behalf of the other presenters, thank you for your attention today. And we'd like to open it up to questions now. Please type them into the chat, and we will discuss and answer them. Thank you.
I see a question. This is Diana Roman from the Carnegie Institution for Science. I see questions coming into the chat window. And I'd like to highlight one from Scott Patterson asking about the plutonic record and whether we're compiling a similar spreadsheet of potential plutons to target, and also raising the question of how do we recognize which of these plutons have also erupted, and that this might be an important focus. I'd like to throw this out to the relevant working group members who might be able to address this question.
Okay, Christy, can you or Ben address this question?
I'm happy to talk about it a little bit. You know, yes, the intent very much is to use a variety of timescales and spatial scales to answer all of the questions and hypotheses that we're testing. And so we are working actively to look at where, for example, in the geologic record, specifically in the plutonic record, we have the opportunity to query the kinds of questions that we want to answer. I think one thing that's slowed us down a little bit is wanting to identify which are the particular hypotheses that we want to test, as this will help enable us to understand, for example, where in the plutonic record is the best to go. So we welcome input through the survey. There's questions to these effects, and also an area for you to fill in whatever else you'd like to add. So we welcome you to add information about what you think would be particular locations or particular hypotheses associated with those locations where they would be good to test.
Thanks, Christy. And I was going to mention we saw a hand raised, and just a reminder to type your questions into the chat window so we can go in order. So here I see in the chat window, we have a question about why passive degassing volcanoes, as shown in Karn and others, 2017, are not included in the restless volcanoes list. I believe they are. Diana, if you could address this question, I thought these volcanoes were included in the list.
I believe they are, but if basically our goal in the current version of the spreadsheet that you can see on the SZ4D website was to list everything in either the Karn study or the FERTNI study, except the ones that weren't on subduction zones. So if you see errors or if there are specific systems that you're thinking of, please do let us know through the survey or through email so that we can make sure that we include these. That was done unintentionally, if that's the case.
Thanks, Diana. And there was another question right after that about is distributed volcanism included in the restless volcanoes matrix? I believe the answer is no, but can you confirm that, Diana?
Yes, and again, basically the spreadsheet as it stands is solely systems that are in the Karn study or FERTNI study, but we are specifically asking you, the community, to tell us which systems that didn't happen to be on those two lists need to be added to our spreadsheet for consideration. So this is a question in the survey, and we would very much like to include systems beyond those in those two studies. So please do give us this input and give us specifics, and we will continue to add your suggestions to our spreadsheet and fill out the corresponding information.
Oh. Thanks, Diana, and I see you answered that in the chat. Thanks. All right, there's a question about, we have very good ways to track volcano unrest once it starts, but not a good understanding on when unrest starts. Will this be considered on the modeling side? And so if I understand the question correctly, this is asking about seeing the run up to eruptions even earlier than we currently do. And I think this is going to be considered on the modeling side. Perhaps, Trish, Greg, did you?
Yeah, I would point to the example that we gave from the traceability matrix. In that particular example, one of the key things we want to understand is what those precursory periods look like. And so numerical modeling was obviously listed as one of the key components to that. So as we get into sort of the nitty gritty of what the science objectives are and what particular hypotheses we want to address, those really do fit within that framework of the traceability matrix, and making sure that we're looking at things from different points of view. And I also wanted to point, there was a question about petrology and looking at real rocks and plutons. Those are also in the traceability matrix. These are ways, of course, that we can really delve into those deeper timescales of volcanic evolution, and they're critical to understanding the current phases of unrest as well. And those are included. I believe we're going to put a draft of that traceability matrix online so that you guys can take a closer look and comment. It's by no means completed, so definitely please give us more feedback and input on that.
Just as a follow-up on that, I just want to mention again that was highlighted at the beginning of the webinar that one big current piece of the SZ4D effort is a modeling collaboratory, which includes a focus on volcano specific models. There was a meeting planned, a workshop planned for this fall, but unfortunately it's been, or this summer, unfortunately it's been postponed due to the pandemic, and hopefully will be rescheduled virtually or in person. But we're very interested in integrating observations and modeling and working with the modeling collaboratory aspect of SZ4D and making sure that all of these efforts are linked together.
All right, and there's a question from Stephen Kuhn asking, could SZ4D address why some centers tend to have frequent activity short repose, whether others tend to have much less frequent activity long repose? And I think that's a great question. And I'm thinking that it's probably, it can find a place in that grid that that Ben described. Ben, this type of question, do you see it fitting into the grid?
Yeah, and I think really the way this fits into the grid is if we can formulate specific hypotheses that are testable. So I think in terms of thinking about repose times, you could think about the different subduction zone variables, and we really welcome your hypotheses. I don't think we can just fill in. We don't want to have just one hypothesis in each box. We want to think about a lot of different ways of thinking about these problems.
All right. And I see there's the next question is from Matt Brisecki. What about structural control on volcanism, pluton emplacement, flux location? Another question that thank you for that question, and we will be discussing it. I think this is the type of questions we want to bring into the grid framework that Ben showed. Next question is from John Sticks. Precursory activity prior to a major event is obviously important. Do you think there are opportunities to make important discoveries in regard to early precursory activity well before the obvious signs of reactivation?
So maybe I could address that. Going to the example that Trish showed on our traceability matrix, I think one thing that we are very interested in is the combined power of some new tools like crystal clocks and in combination with monitoring data. And one of the, I think, big open questions in this regard is, do they tell the same story or not? Do things happen before we actually see them in our monitoring data? So this is already on the traceability matrix in some form, I think, but we'd like additional input from you on whether we can go farther and make additional observations to address this question.
And just to add to that, this is Adam and Kent. One of the ideas between trying to observe entire eruption cycles would be to be able to look at exactly that question, because we would see the full repose period between eruptions.
All right, and the next question is from George Zelmer. I am missing a bit the petrological observations on past eruptions, which will be key to understand the plumbing systems. Experimental petrology was mentioned, which is indeed important, but we need to take apart the actual rocks to look at the plumbing system dynamics and geometry so that we can focus the geophysical observations appropriately. So did someone from one of the presenters wanted to discuss the petrological observations?
I'd be happy to do that. Yeah, this is a great question. So our strategy thus far has been to identify the primary hypotheses that we want to test, and then think of all of the types of data that we would need to collect to test them, and of course at what locations would be best to collect that type of data. So the hypothesis grid that Ben introduced is in the survey, and we invite you to go, and then also to then step into the question of what is the types of data that you think are the most important to collect to test that hypothesis in the survey. And if you have thoughts on locations, that is definitely welcome as well. So we're using this process, and if we had time to delve into the traceability matrix, you would see that petrologic observations are definitely key, and they come up in pretty much every hypothesis that we have identified to test so far. And so we absolutely plan to include those.
Thanks, Christy. The next question is from Suzanne Straub. The impact of a volcanic eruption depends much on its size. What's the strategy in collecting, linking data on to eruption size? So first thought that I can think of is really this is a great question for connecting to the outcomes of Converse. Thinking about the strategy in collecting and linking data perhaps that's in rapid response mode, but let's see. Does anyone of the presenters have?
Sure, I can maybe make a comment. So I think to date, we've addressed this in a very limited sense in our restless volcano spreadsheets by using VEI as a proxy. And we all know that VEI is an imperfect proxy and that there's much more of a need for follow-up in-depth syneruptive and post-eruptive characterization, and that many of the key observations in the deposits are ephemeral. So I think Matt's point about converse is critical, but at the same time, we will have to be specific in how often we can do that and the extent to which we can do that. So this will be a place where we may need to pull in more information from remote sensing. There are very interesting things going on in the acoustic community about proxying eruption size. Ideas on how we might creatively solve this problem are very much welcome.
Thanks, Diana. And our next question is from Scott Patterson. Can you share with us upcoming deadlines and next steps? For example, do you need to get back to NSF with proposed next steps at a certain time? I don't think we're at that very specific point yet, but Christy, you gave the road ahead slide.
That's right. Natalie, would you mind going back to the road ahead slide? It's, yeah, 2 more back. So we're at this juncture here where we're this is the first broad discussion of the work of the Magmatic Drivers of Eruption Working Group with you, the community, thus far. And obviously, for those who couldn't be here today, the recording and the slides for this are available on the MDE website through SZ4D.org. And we'll have that webinar survey open through the next couple of months to collect input. So then over the summer and fall is when we kind of are transitioning into the beginning of talking about all of the traceability matrices and all of the data. So we don't have a specific deadline with which we're going to sort of nail in science questions, but over the sort of next 6 months is the time when that we envision that happening, and moving into implementation plan, draft planning in early 2021. Our ultimate deadline to have everything in place for sharing with funding agencies is fall 2021.
All right, thank you, Christy. And the next entry in the comments is it's more of a comment from Alan Lerner that is thanks for pointing this out. Alan says Carnadal's database of degassing volcanoes is a good start. However, Alan notes that satellites with much higher resolution for UV measurements of SO2 have recently come online. For example, Tropomi. So we will hopefully soon be able to identify a greater number of volcanoes with lower level but persistent SO2 degassing. So something for us to keep in mind that list may not be stationary, but there could be improvements in measurements that add more volcanoes. Here's a question from Kevin Reith. Volcanic eruption triggers seem to be separated between internal and external triggers. What would you consider triggers such as the Mole 2010 earthquake, increasing unrest that led to an eruption years later? For example, so this is looking at an eruption that could be delayed. Adam, I think you gave this slide on these mechanisms. Could you field this?
Yeah. I mean, this is a good example. We're not presenting what we have here as the final word, but we recognize that we can divide eruption initiation mechanisms into 2 broad families. That doesn't mean they don't interact. And so, as we emphasized, understanding what are the key components within Magmatic plumbing system to make them suitable to be initiated by some external mechanism like an earthquake, and exactly how that might happen is right down the middle of what we're thinking about. I can't give you an answer, but I can say that's sort of an example of one of the important sets of questions and hypotheses we're definitely thinking as part of this initiative.
Thanks, Adam. All right, the next question is from Dave Hyman. How do you hope to ameliorate the sampling bias inherent to constructing these lists? I am thinking of critically under-monitored volcanoes and non-monitored volcanoes where restlessness has probably been missed and therefore have not been included in the list. For example, how do we know that Raikoke should not have been in the list until last June? Diana, could you address?
I get the difficult question. Absolutely. We're very aware of this bias in not only this implementation development, but also in the field in general. And we don't know that Raikoke should not have been on the list. It was not observed to have been degassing. We do not know because of its small footprint whether it was deforming. And the hope is that this is, again, an opportunity for the remote sensing community to bring us to the cutting edge of early detection of more subtle signals as new tools begin to come online for remote sensing detection of deformation, degassing, thermal signatures, and so on. And this is really key. We need to maybe think about a strategy within our program that might keep an eye on interesting signals in remote sensing that we might choose to target through our rapid response effort. So I think we're all trying to think about strategies, implementation strategies that would allow us not only to find these, but then also to start to focus on them more.
Thanks, Diana. The next question is from Kristen Nicolaisen. The recently released Vision for the Earth Sciences 2020 through 2030 by the National Academies emphasizes diversifying human infrastructure. What is the vision of this initiative related to diversification of people in the geology pipeline? And I'll just point out first that this is a great question, and there is an entire chapter in the SZ4D vision document related to this topic on inReach and outreach and capacity building. And it's something that even this past week, I've been emailing with Harold Tobin about. So I think this can be addressed at the SZ4D level within the umbrella RCN. Did anyone have any additional comments on this question, or Harold, if you're on the call?
Yeah, I'm here. I think there are some comments that have been added in the chat, but bottom line is basically that it's true that the working groups so far have spent their time focused on the science questions, but there is much work to be done as far as this planning process goes to develop exactly how SZ4D will then develop that reach, especially down into the educational pipeline. It's on our minds, but we don't have something to present yet about specific activities, and we definitely welcome input from across the community on exactly what things might make the most sense.
All right, thanks, Harold.
It's worth adding the comment that Adam Kent just added at the bottom too, that a specific sensitivity for this group you guys may want to talk about is that we're talking very specifically about volcanoes which are geographically placed and have populations around them. So international partnerships is another key part of that and part of the educational effort as well.
Excellent. Well, I'm just catching up with all the comments I haven't seen yet. I will note that we are coming up on the top of the hour, and people may need to move on to other meetings, but we'll continue to go through the questions. The next question is from George Zelmer. I guess it is important to allow collaboration between geophysics and other aspects, and geophysics requires active volcanoes, which limits the number of volcanoes with very large eruptions that erupt rarely. This is a good point. That looking at the restless volcanoes spreadsheets is something to keep in mind, that eruptions like Montserrat that only happen very rarely, it does place some limits on the investigation. Adam Soule has a question. A quick reminder that 1/3 of arc volcanoes are submarine. Although they are much harder to monitor, they also present some unique boundary conditions. For example, high hydrostatic pressure that may be useful in isolating arc volcano behavior more generally. Thanks for this comment. Something that as we think big, we can also begin to think about submarine volcanoes. Oh, and I see that Christy has further answered the previous question from George Zellmer. And maybe I'll just read Christy's response. Those types of observations are absolutely being considered. The idea is to identify hypotheses and then all the types of data that will test that hypothesis, to which petrology is key to many. And then where do we go to test those? So providing input on hypotheses to test methods on how to test those via the science traceability matrix, and then where to go to test them is very welcome at this stage, in addition to those we have identified so far. All right, and I think there are also further comments to Adam Soulei's question about submarine volcanoes that I'll get to. Here's a question, I believe this is directed to Christy from Snir Atia. What are the actual opportunities to provide input on the hypotheses and ideas to be considered?
That's right. As I responded in the chat, we absolutely want your input. And so if you go to the webinar survey and provide us input, that is intrinsically going to be part of the process going forward. And we will incorporate all of the feedback that we're getting today in how we can revise and restructure and ultimately end up with the science drivers and the science traceability matrix that we're going to use from here on out. So when we say we want your input, we are quite serious. And then also, this isn't going to be the only stage for input. As we start having a draft implementation plan, we envision also asking for community input at that stage as well. So input into the science drivers now, input into the actual execution of that plan in the next phase. So yes, please participate.
All right, thanks, Christy. And I see Christy also has replies to Kirsten and then also the reply that she just further replied to now. Cynthia Ebinger has a question. Implementation, will NSF fund data acquisition projects with NPIs and then individuals submit proposals for analyses? Let's see, I don't know if we've gotten to this level of detail, but if I understand it right, is this thinking about the different phases of the approach, and this would be looking at more focused sites. So then how do we bring together the NPIs?
I can maybe just address that quickly, just to say that yes, we're in this big scale planning phase, and there isn't an NSF program now. It's not, for example, that it's got a cookie cutter approach that looks like the way, I don't know, GeoPrisms or EarthScope or something else did something in the past. So that's going to be an active discussion. There are a few NSF folks on this call, and you're welcome to unmute and say something. But I think the short answer is we don't know yet. There's a number of ways that actual field programs could be structured, and we welcome input on all of those as well.
All right, thank you, Harold. And I'm catching up with the discussion. It's great to have all these questions. I see several of the presenters have been answering the questions in the chat window. Here's a question from Meredith Townsend. In the context of SZ4D, which plans to understand how subduction zones evolve over time, I am wondering to what extent this group will address more basic science questions about how melt is produced and how mantle and crustal magmatic systems come into being and evolve over time and eventually die out. Volcano eruption forecasting is important, and perhaps this one group cannot try to tackle all aspects of archvolcanism. But I am just wondering to what extent these other aspects would be considered relevant to the goals of this group. Let's see, Ben, could you field this question?
Yeah, so I was busy actually answering other questions in the chat. Was this is Meredith's question?
Yes.
Yeah, so as I mentioned in the chat, I think this is a great question that Meredith is bringing up. And as I think we noted in the chat, the scope of the MD group is from the mantle to the surface, and it's the evolution through time. So absolutely, this is part of what we're thinking about, and how really and it's part of the interface with the broader subduction system. So it's thinking about how processes in the larger subduction system and magma generation are connected all the way through to volcanic hazards at the surface. Yeah, so definitely.
All right.
Thanks, Matt.
Thank you.
If I might piggyback on that, we have specific hypotheses that test questions about flux, for example, like generating what is the flux from the mantle into the crust, or related things in terms of time, like what is and that flux has, a time component to it. So that is one that we've identified already, but we would definitely want to hear more hypotheses in that regard from you in the survey.
Yeah, I want to jump into just for a second to say in the science traceability matrix, one of the main themes in several of the science objectives is this question of mass balance, and what does it look like going all the way from the subduction to the surface. So yeah, this is definitely something that we're very interested in and would love more input on and other ideas on this.
And I will chime in too. This is Terry Plank. This is such a great question that unites a lot of what we're going to do. It's why SZ4D is exciting, because it's really trying to make new connections between the volcano scale and the eruption scale, and even what's happening in the mantle. We haven't really been able to do that, but the idea that we could tie mantle production rates to mass supply rates to the way magma moves to the crust and erupts is exactly what we're trying to do, as well as through the evolution of a volcano. So thanks for bringing that up.
Thank you. Oh, and I did have, we will get to the questions, but I had a request come in from Denny Geis that he would like to make a brief statement from NSF, and he needs to go here pretty soon. So Denny, if you'd like, please unmute.
Okay, thanks, Matt. Yeah, I just took the bait that Harold offered. And right now NSF's at a fairly early stage in thinking about this. With the CORS report having just been released, much of anything that we do will have to be based on that. So we're starting to think inside NSF, and it's going to be an incremental process, I think, between the community and the foundation. And I also really want to congratulate the conveners of this session and the website that you're building and so forth. You're doing an excellent job of letting the science drive the questions, and I think that's really important for all aspects of the SZ4D initiative. The other thing I want to say is just addressing Cindy's question, is that even without the SZ4D, just remind you that core programs and some of the interdisciplinary programs like FRES, we're actively funding tons of subduction zone research, anywhere from 1 to 10 PIs on specific subduction zone questions that are tractable from smaller than community efforts. So keep the great subduction zone proposals coming in, and I wish I could offer something more substantive, but it's still in progress.
All right, thank you, Denny. And I see going through the chat, there's still a lot of great discussion. Thank you, everybody, for fielding the questions in the chat. And one of the comments was to capture the chat history, and Harold has said that we will save the chat from this webinar. Looking here, I think there's only one more question, and I see the number of participants is declining as we go past the hour mark. People needed to move on to other meetings. I think there's one more question, and Adam has addressed this in the chat from Bradley Pitcher. How will we decide whether to include rear arc volcanoes in these studies? It is clear that there is at least a slight subduction zone flavor from many of these volcanoes, although perhaps not considered strict arc volcanoes. Adam, did you just want to paraphrase your comment for the group?
Yeah, I said we're certainly open to that feedback, and particularly if there are good rear arc volcanoes to add to our Russus volcano list, please go and do that. I don't think we're thinking not so much in terms of drawing restrictive boxes at this point, but trying to, as Danny sort of echoed, let the science be the driver, and the rear arc volcanoes are part of subduction zone systems, so I feel like they're important.
All right, thanks, Adam. And with that, I am looking at the chat window, and I just wanted to thank everybody again for the feedback, and yet just one more reminder with this slide up to visit the website and look at the materials that have been placed there. And with that, I'll bring our webinar to a close. And one final reminder about the upcoming faulting and earthquake cycles webinar next week at the same time, and then 2 weeks, landscapes and seascapes. So again, on behalf of all the presenters, thank you